Bismillahirrahmanirrahim. Dr. Mohammad Yusuf from the Department of Chemistry, Islamic College, Peshawar is here. Today we will talk about the structure of carbonyl compounds. And second is the reactivity of the carbonyl compound. So first let's study the structure of the carbonyl compound. Here this carbon of carbonyl compound is sp2 hybridized. Oxygen is also sp2 hybridized. We have double bond between carbon and oxygen. One is sigma bond, one sigma bond. This bond between carbon and oxygen is formed by the sp2 hybridized orbital of carbon with the sp2 hybridized orbital of oxygen, while one bond is pi bond. This pi bond is formed by the p-p overlap. p-p overlap. Unhybridized p orbital of carbon sidewise overlap with the p orbital of oxygen, and this gives rise to a pi bond. So here the carbon-oxygen bond consists of a sigma bond, which is formed by the sp2 and sp2 overlap of the hybridized orbital of carbon with the hybridized orbital of oxygen atom, while the pi bond is formed by the sidewise overlap of the p orbital of carbon with p orbital of oxygen. That's why the overall shape of the molecule is planar. The overall shape of the molecule is planar with angle of 120. Here it is 120, 120 and 120. This carbon-oxygen double bond is having a bond length of 1.23 angstrom, and it is shorter than that of ether and that of alcohol. That is, the carbon-oxygen double bond here is shorter than the carbon-oxygen single bond in ether and carbon-oxygen bond in what? Alcohol. Now, after discussing the structure of carbonyl compounds, we are now going to discuss the reactivity of the carbonyl carbon. The structure, remember, inorganic compound, the most important point is that the structure will affect the reactivity of a particular group or a particular compounds. Here, if we look to the nature of this carbon-oxygen bond, then it is polar. That is, carbon-oxygen bond is polar. Polarity is due to two phenomena. I will say two phenomena. One phenomena is the difference of electronegativity. Oxygen is more electronegative and carbon is less electronegative. Due to this reason, the electron will be attracted more toward oxygen than carbon, with the result that oxygen will be having slight or partial negative charge and carbon will be having a slight or partial positive charge. This polarity is partial polarity. Here you see we are having partial polarity. Partial polarity means due to difference in the electronegativity. As the bond is covalent between carbon and oxygen, but due to electronegativity difference, the electron is more shifted toward oxygen, and hence it is partial negatively charged and is partial positively charged. This is one reason for polarity. you may number it is 1. That is difference of electronegativity between carbon and oxygen render this bond is polar. The second cause of polarity is permanent polarity. How this permanent polarity is caused? Here in this structure, if you look, here we are having complete negative charge in oxygen, on oxygen atom, and complete positive charge on what? Carbon atom. Why this happened? This happened because this pi electron is shifted completely toward oxygen and you get this structure. So here we are having complete polarity and here we are having partial polarity. Whether it is partial polarity or whether it is complete polarity, in any case, remember, in any case, carbon bear a positive charge. Maybe slight positive charge like this, or maybe complete positive charge like this. Due to this positive charge on carbon, it acts as an electrophile. Carbon acts as an electrophile. And if it is electrophile itself, then it will be definitely attacked by a nucleophile. If it is electrophile, either due to partial positive charge or complete positive charge, it will act as electrophile, and if it is electrophile, it must be attacked by a nucleophile. Therefore, the most characteristic reaction of these carbonyl compounds are the nucleophilic addition reaction. So nucleophilic addition reaction, these are the most dominant type of reaction which take place in these carbonyl compound due to partial or complete positive charge on carbon. You can represent this general nucleophilic addition by this mechanism, general representation of nucleophilic addition. Here we are having this carbonyl carbon and we have got this nucleophile. This nucleophile will attack on positively charged carbon, which may be either slightly positively charged, completely positively charged, depending upon the medium of the reaction. So here, this nucleophile will attack on this carbon. The reaction will be catalyzed either by acid or bases. That is, the reaction will be catalyzed either by acid or by bases. This nucleophile, when attack on this carbon, it shifts this electron over here. So here, we are having now the nucleophile attached completely with this carbon as in this structure, and the pi electron is shifted toward oxygen with the result that the oxygen is negatively charged but completely negatively charged. Remember, this negatively charged oxygen may attack on the positive species. Where this positive species may come? It may come from this one, because if you take a polar molecule, it may be having one portion which is nucleophile and the other portion which is electrophile. So it will be attached over here and you will get this addition product. Remember, in the starting, you are having sp2, a hybridized carbon, this one. But here, now we are having completely sp3 hybridized carbon. Therefore, the starting material was planar and now the end product is tetrahedral. The nucleophilic addition, as we have discussed right now, may be either catalyzed by an acid or a base. Acid catalyzed reaction. Look over here. In carbonyl compound, the oxygen bear a lone pair of electron. Look over here, oxygen bear a lone pair of electron. And therefore, due to this presence of electron, they can act as weak Lewis bases. They can act as weak Lewis bases. If this lone pair of electron or oxygen is donated toward an acid, then here we will get oxonium ion. Remember, when oxygen bear a positive charge, it is oxonium ion. In this oxonium ion, oxygen bear a positive charge, therefore it will shift what? The pi electron toward itself in order to cancel its positive charge. That is, oxygen, when it forms 3 bonds, it bear positive charge. In order to neutralize its charge, it will shift the pi electron toward itself, and this will shift the total positive charge toward carbon. So here in these 3 structures, you see over here the charge is slight. Here it is also slight, but here I have denoted the positive charge by a bigger sign. It means now it is complete positive charge. Here it was slight positive charge, here it was slight positive charge, but due to the donation of the electron pair by oxygens toward the hydrogen ion, the pi electron is shifted and carbon become completely positive charge as over here. Now, if the nucleophile, the attacking nucleophile is a weaker one, then it is not possible for this weak nucleophile to attack over here because of the small positive charge. But now, if we use this acid catalyst, then the slight positive charge is converted into a complete positive charge, and now it is even for a very weak nucleophile to attack on this positive charge and carry the nucleophilic addition. So that's why we say that acid catalyst must be used while carrying out the nucleophilic addition across the carbon-oxygen double bond. With a weak nucleophile, the catalyst must be what? It must be acid. The second type is base catalyzed nucleophilic addition. Here, remember, this is a nucleophile. This is a nucleophile. This nucleophile, remember in your book in second paragraph, a sentence has been written. Do not get confused with that sentence. Over here, it has been written that the base react with the reagent to generate the nucleophile. What is that base? The base catalyst. The base catalyst. The base catalyst will react with a reagent. What is that reagent? The reagent which is used for this addition. The base will react with the reagent to generate this nucleophile. But remember, this nucleophile is a stronger one. Stronger one. And if this nucleophile is a stronger one, even it can attack on this slight positive charge. Over here, the nucleophile was weak and was not possible for this nucleophile to attack on this slight positive charge. But here we are having a strong nucleophile. Therefore, it is possible for this strong nucleophile to attack on this slight positive charge. When this strong nucleophile attack on this positive charge, the pi electron will be shifted toward oxygen, with the result that the N nucleophile will become permanently attached with the carbonyl carbon, and negatively charged will be shifted toward oxygen. In the subsequent step, in the next step, this negatively charged species may react with a positive species like this one to give you the final product, and again a nucleophile is generated over here. This nucleophile will come again and will repeat this step. So in summary, we may say that nucleophilic addition reaction may be either catalyzed by acid or by a base. But under what condition it will be catalyzed by acid? if the attacking nucleophile is a weak. The weak nucleophile is unable to attack on the slight positive charge, therefore it must be first completely converted into a complete positive charge on carbon. Base catalyzed reaction will take place with a strong nucleophile. A strong nucleophile like this one even can attack on slight positive charge. Therefore, these 2 points should be kept in mind. They are important from exam or MCQ point of view, that if strong nucleophile is there, the catalyst must be a base. And if a weak nucleophile is this one, then the catalyst must be an acid. With this, thank you very much, and thank you for listening to me.